Hey, the great news today, lesson 410. We're at the end of chapter 4. We're going to close that book and start chapter 5 here really soon. Today in lesson 410, we're going to talk about transforming linear functions. We're going to talk about family of functions and our parent function. And because we're talking about linear, our parent function, our mother function, is simply y equals x. Transformations, this is our objective, describe how changing slope and y-intercept affect the graph of a linear function. These are the two transformations that we're going to talk about, a slope change and a y-intercept change. So get these vocabulary terms down and then we'll proceed. All through your study of mathematics, we talk about family of functions because we are in algebra. We will talk about the linear family. It comes in the form y equals x or f of x equals x. Later on in the year, this year, we'll talk about quadratic functions. But for right now, our parent function for our family called the linear functions. Parent function is y equals x, right here, as I said earlier, f of x, which we know to mean y, a function of x, which is just y. Y equals x is our parent function. The graphs of all other linear functions are transformations of this graph, of the mother function. A transformation is a change in position or size of the figure. There are three types we're going to talk about. They are translations, rotations, and reflections. Look at the four functions and their graphs below. We have y equals x, or g of x, which is the same thing as y equals x plus 3, y equals x, the blue graph, y equals x minus 2, and y equals x minus 4. Here's what's happening. From the parent function, we know we're going to relate everything or compare everything to this blue line, which we see right here, y equals x. G of x has slid up 3 units. Notice its new y-intercept plus 3. This is y equals x plus 0. Our y-intercept has changed, therefore the graph has slid up 3. X minus 2, obviously we've slid down 2, new y-intercept being negative 2, and y equals x minus 4. The parent function slid down 4 units. And here's the explanation. These are called vertical translations. A translation is a type of transformation that moves every point the same distance in the same direction. You want to get that definition into your notes. A translation is a slide, taking every point the same direction and the same distance. We think of them as slides. Here's your official definition. If b increases, we know b to be our y-intercept. If b is increasing, the graph translates up. If b is decreasing, if we see y equals x minus some value, it's translating down. So let's look at the translation here. It says we start with the graph f of x equals 2x, and we're thinking, what is that 2 doing? That's our m value. So instead of 1, we're going up 2 over 1. So our graph is now steeper, but we're taking that function f and doing what to it? We have a translation here, a slide. We know that this graph, y equals 2x, notice the slope up 2 over 1. All points have slid down 6 based on that new y-intercept. We can use our calculator to see these quickly and easily as well. So the graph g of x is the result of translating f of x 6 units down. Try this one. Check it out. Graph both and then describe the transformation from f of x to g of x. So if we study this first one closely, we're starting with the parent function but 4 units up. So we take the parent function y equals x. We started 4 units up because of this new y-intercept. So from here down to here, we have to compare to this first graph. We're at negative 2 now. We're going to take a look at our y-intercepts from 4 to negative 2. We see a difference of 6 units. this has slid or translated 6 units down from its original position. The graphs g of x equals 3x, h of x equals 5, k of x equals 1/2 x. Those are all of our slopes. We notice they have no y-intercept other than 0. They're all going through the origin, which means they are direct variation graphs. But when it comes to comparing graphs with different slopes, we use the word rotation. It's a transformation about a point. In this case, our fixed point is 0, 0. You can think of a rotation as a turn. The y-intercepts are the same, but the slopes differ. So go ahead and get this definition in your notes. When just the slope changes, we have a rotation. F of x equals x. We're starting with the parent function. G of x equals 5x. We want to graph those and describe the transformation from f to g. Remember, we can name a function anything we want. This could be q of x, triangle of x, giraffe of x, doesn't matter. Any name is sufficient when naming a function. So here's our first graph, y equals x. Here's our second graph, 5x. Notice we went up 5 over 1, much steeper than up 1 over 1, which is the slope for our parent function. So we would describe this by saying the graph g of x, excuse me, I bet that hurt your ears. G of x is the result of rotating the graph f of x about the origin. G of x is steeper than f of x. So you guys try, check it out, example 2, and see what you come up with. So 2 observations I want to make before I get started on determining transformation. I want to compare the slopes, mx plus b. This is in slope-intercept form. And I see a slope of 3. For g of x, I see a slope of 1/2. So I know there's going to be a rotation, but we have the same y-intercept. So we know this is our point of rotation. At -1, both lines pass through. 1/2 x compared to 3x, our graph f of x, which is the first one, rotated clockwise to g of x. So we say it's a rotation, and we could say clockwise to be more specific. It is also less steep. We would add that. 3x, much steeper than 1/2 x. This diagram shows the reflection of the graph f of x in blue across the y-axis g of x. Notice the slopes. Look at the comparisons. A reflection is a transformation across a line that produces a mirror image. You can think of a reflection as a flip. So now we've got slides, rotations, and flips. So a slope of 2 and its opposite are reflections. Here's a quick, nice, easy definition. When the slope m is multiplied by -1, f of x equals mx plus b, the graph is reflected across the y-axis. So with that in mind, let's look at f of x now, the function 2x plus 2, and reflect the graph across the y-axis. Write the function g of x to describe the new graph. Well, we were just told that multiplying the slope by -2 gives us a reflection. Notice all that's going to do is change the slope. Our y-intercept is maintained. It stays the same. Multiplying the slope by -1. You guys try this one. Check it out. Number 3, we're going to start with the graph 2/3 x plus 2, reflect that graph across the y-axis, and write our new function. So in graphing this, our function f of x has a slope of rise 2, run 3. We can see that here. Your new function g of x, same y-intercept, so the 2 would be the same. And now we can see we rise 2 and go back -3. So our new function would be -2/3 x plus 2. What if multiple things are going on? Let's look at f of x equals x, our parent function, and compare it to g of x, 2x minus 3. Describe the transformations from f to g. When we see our graph f of x equals x, we're going to graph g of x, that's 2x minus 3. So we plot our y-intercept, and then we use our slope up 2 over 1, and we're going to compare it to the original function. Well, we can talk about two things here. Our slope has increased, and our y-intercept, we have slid down 3 units. First, we multiplied f of x by 2. That rotates it about the origin, so that's our green line. And then we slid it down 3 units. That seems easy enough. You can do this in whichever order you want. We could have slid the blue graph down and then rotated it about the point. So you guys check it out. Number 4, it says graph the function, the parent function, and then graph the function g of x, negative x plus 2, and describe the transformation from graph f to g. And away we go. So we're looking at the parent function, and we're looking at our new function g of x, which is negative x plus 2. First comparison, positive 1, negative 1 slope. So I know this is a reflection across the y-axis, and I see that their y-intercept has changed. So we're going to have a slide upward of 2. First thing they do is take the blue function, the parent function, and rotate it according to the slope. It went from positive 1, up 1, over 1. Now it's up 1, back 1 to take care of the negative slope, and then they translated it up, so from a 0 intercept to a positive 2 intercept. That seems fairly simple. So you guys go ahead and check it out. Example 5, it says a trophy company charges $1.75 per trophy plus 20 cents per letter for engraving. The total charge is given as the function 0.2 times x, that's per letter, plus $1.75. And notice that if it's 0.2, this is 20 cents. They've changed $1.75 into cents as well by removing that decimal. So the graph in blue is our original function, 20 cents per letter, and $1.75 or 175 cents. How will the graph be affected if the charge per letter is lowered to 15 cents? If the charge is lowered, the new function, the red function, has a lower slope, understanding that that price per letter is our slope. Trophy charges $1.75 plus 20 cents. What if the graph changed, the cost of the trophy is raised to 180 cents? So from the blue graph to the green graph, we can see an original cost without any letters from $1.75 to $1.80. That's a translation or a slide upward. If the charge per trophy is raised to $1.80, the new function, the original function, is translated 5 units up. Go ahead and complete this quiz and come back and check your answers. So we have just enough time to go over these quiz questions. It says to describe the transformation from f of x to g of x. We notice only one thing happening, the slope from positive 4, rise 4, run 1, to a positive 1 slope. So we have a rotation about the point 0, 0, and it's going to be much less steep. For number 2, x minus 1 to x plus 6, we start with a y-intercept of negative 1, slope of 1, but this is translated up, slid up, 7 units. 3, 1/5 x to 2x. The only thing happening is a change in the slope. We're going from rise 1, run 5, to rise 2, run 1. We have a much steeper slope. Rotated again about the origin because the y-intercept has not changed. And finally, f of x 5x to negative 5x, we know this is a rotation.